All right, I'm going to go over the Unit 1 review. Hope this is helpful for you. And let's go to work. Start with blue. Determine if the following is a function or not. Number 1 is not a function because the y has an exponent. That's how I know. Number 2, I have all different inputs, therefore it has to be a function. In order for me to have a table that's not a function, I would first have to have a repeating input, and then that repeating input would have to have different outputs. Number 3, input, the number of candy bars purchased, output, the amount of money spent. Now this is kind of tricky, and because I could think for myself, I could say, hey, well, I could buy, 3 regular candy bars and 1 giant candy bar or king size, and that would be a different price than 4 regular sized. So I have to be specific, and I'm going to say this is not a function. And we could argue about whether it is or is not, but I think we have some candy bars would have different prices. Therefore, that's why I'm saying it's not a function. If you go one way or the other and you're not sure, you better give an explanation, just as I did verbally, but you would need to, if it's on the test, explain in writing. Number 4, input a person, age of a person, number of hours spent playing video games. Well, I'm 46 years old, and I've spent about 12 hours playing video games. And my buddy's 46-year-old, and he spent millions of hours playing video games. So the age has nothing to do, therefore it is not a function. Number 5. 5 and 6 are easy. I'm going to use the vertical line test. And number 5 is yes, it's a function. And number 6 is not a function. It fails the vertical line test. Boom, right there. It touches it twice. We'll assume that's a nice straight line. Number 7, yes, this is a function. And number 8 is not a function. Well, how do I know these? Well, anytime I have a sequence, if there's no or, like in number 7, there's no or in there, so it's a function. But number 8, I see an or there. That tells me it's not a function. Okay. It didn't ask me to tell the domain, but the domain of every function is always from 1 to infinity, and then the range is whatever you see. Number 9, give an example of a function in words. So I need to give an example. Let's say, let's go with input being age and output being number of birthdays. Okay, so if somebody's 48 years old, they've had 48 birthdays, right? So that would definitely be a function. Input would be age, output would be number of birthdays, domain would be from 0 to, I don't know how old the oldest person is. I'll say 0 to infinity, because we never know what could happen, but we'll go with that. Number of birthdays would also be from 0 to infinity. Okay. Page 2. Numbers 10, 11, 12, I'm going to give the domain and range. Now, for number 10, I'm assuming this thing goes on, so my domain would be from negative infinity to positive infinity, and my range stops right there, so it would be from negative 5 to infinity. Number 11, this bad boy goes from there, so that's negative 6 to infinity. That would be my domain. And then my range is from -3 to infinity. Number 12, number of students in a class, 0 to, again, I'll say infinity for a lack of a high number, would be my domain. The number of birthdays in the class. Well, however many people I have, that's how many birthdays we would have. So that would also be from 0 to infinity. Number 13 and 14, I got to use f of x and h of t to evaluate the functions. So basically, I'm just plugging them in. So number 13 would be 1/3 times 3 minus 4, which is 1/3 times 3 is 1. 1 minus 4 is a -3. F of -6 would be 1/3 times -6 minus 4. So f of -6 would be, well, that would be a -2 minus 4 would be a -6. Number 15, I'm going to plug in 3. Now I'm plugging this into the h value. So h of t would be a negative. Now this is negative sign, causes a lot of people a lot of problems, because some people refuse to put a parenthesis around what they're plugging in. And see, that negative sign belongs on the outside. So 3 squared is 9, but this negative sign also stays because it was on the outside. It's not -3 squared, it's 3 squared. And I want the opposite of that, or the negative of that. And then plus 6. So -9 plus 6 is -3. So h of 3 is -3. Same thing on this next one. Now I've got -2 squared plus 6. So this negative on the outside is just going to sit there. Well, -2 squared is a +4, but that negative on the outside just sat there. So -4 plus 6 is 2. So h of -2 is 2. A lot of people, that negative sign messes with a lot of people. Okay. Next one, I got to choose my inputs and then fill out the table and graph. Well, number 17 is a square root function. Anytime I have a square root function, I want to be thinking of these perfect squares. 0, 1, 4, 9, 16, 25, 36. But I'm not just plugging those numbers in. I'm thinking to myself, that's what I want under that radical. So what can I put in for that x to get x plus 8 to equal 0? And that's my input. Well, that's a -8. What plus 8 gets me a 1? Well, that would be a -7. And a -4, and a 1, and an 8. Now, when I plug those numbers in, -8 plus 8 is 0. The square root of 0 is 0. -7 plus 8 is 1. The square root of 1 is 1. -4 plus 8 is 4. Square root of 4 is 2. 1 plus 8 is 9. Square root of 9 is 3, and so on. So then I plot those points. -4, 2, 1, 3, 8, 4. And there is my graph. Sometimes we call that a flare. Looking at 18, there's no fraction, there's no square root, so I can use pretty much whatever I want. So I would choose -2, 1, 0, 1, and 2. Plug those in. -2 squared is 4. 4 minus 5 is a -1. -1 squared is 1. 1 minus 5 is a -4. 0 minus 5 is a -5. 1 squared is 1 minus 5 is a -4. 2 squared is 4 minus 5 is a -1. Plot those points. -2, -1, -1, -4, 0, -5, 1, -4, and 2, -1. And I've got myself a nice looking parabola there. So there's the second page. Moving on. Calculate or estimate the average rate of change and the initial value from -2 to 2. So my rate of change and initial value. Well, from -2 to 2, I go over 1, 2, 3, 4. I went over 4 and I went up none, so that's 0. My initial value is where it crosses the y-axis, so that's 7. Looking at number 20, this one's a little bit more difficult. I'm going to have to find f of -2, which is -2 cubed is 8. Sorry, it's a negative 8. And then negative 2 times a negative 2 is a positive 4. So that is negative 4. So that first point is negative 2, negative 4. And I got to do that again. I got to find f of 2 now. Well, 2 cubed is 8. Minus 2 times 2 is 4. So that is 4. So the second point is 2, 4. Now I use my my slope formula and go negative 4 minus 4 over negative 2 minus 2, which is negative 8 over a negative 4, or 2. And then my initial value is right there on the end. So my rate of change here is 2. And my initial value is 0. Because there's no... I could plug in f of 0 if I wanted and realize that that's 0 minus 0, which is 0. But that's doing it the hard way. Number 21, I'm still finding for 21 my rate of change and my initial value. That's the question here. Okay, a homeowner's made a down payment of $10,000 and pays $700 each month for his mortgage. Think about the function. It shows the rate of blah, blah, blah. It shows how much money has been spent in terms house and months. Well, my rate of change is $700 per month. And my initial value was the $10,000 down payment. Okay, that was easy. Number 22, my rate of change. I want to go from negative 2 to 2. So that is 16 minus 1 over 2 minus negative 2, which is 15 over 4. And my initial value is 4. How we doing? Good, I hope. Now, 23 and 24, I got for the following functions, tell whether it's linear or nonlinear. Give the domain where it's increasing and where it's decreasing, and then give a maximum or minimum. Okay. So 23 is nonlinear. Okay. It is increasing from negative infinity to 5, and then it's decreasing from 5 to infinity. And it has a maximum at the point 5, 2. So the max value is 2. All right. Number 24 is linear. It is increasing from negative infinity to positive infinity. It does not decrease and has no max or min. Cool. Last page. We did not have to do 31 or 32, so these will be my last few problems here. Answer the following questions. Given the function, modeling the height and feet of the angry bird that is thrown in terms of time. So we got an angry bird. Flying through the air. All right, what does the point on the graph represent? We're talking about this point right here. Well, that means that angry bird is that angry bird. Oops, can't spell angry. Angry bird is 6 feet high after 1.5 seconds. Okay, number 26. Based on the graph, what is causing the height of the bird to decrease? Well, I don't know if they have a cause, but the independent variable is time. So time is the independent variable. They don't give us a function. They don't tell us anything. I mean, I'm not going to assume that it's gravity But I don't like the fact that they ask whether it causes, because we're not talking about a cause and effect kind of relationship here. We are talking about a relationship, but since it's an angry bird that's kind of thrown up in the air, I'm guessing that's going to be gravity that's causing it to fall back to the earth. You know what I'm saying? That's a bad question, and I don't like it. I hope that I don't have one that's that bad on the test tomorrow. Okay. Number 27, what's the maximum height the angry bird gets? And when does the bird reach it? Well, it gets 8 feet high after 1 second. That's the maximum. What inputs make sense? Inputs make sense from 0 to 2 seconds, because this area here and here would represent below ground level, and that's not what we're talking about. Number 29, during what time is the bird's height increasing? From 0 to 1 second. You can see it's increasing right here from 0 to right there, which is 1 second. And then what are the different heights the bird reaches? From 0 to 8 feet. So that was your review. Hope that you were able to do that and complete it correctly. And good luck on your test tomorrow. Have a great day.